This is a lesson on simplifying expressions, which involves combining like terms. When simplifying expressions such as this, we look for the common pieces. Here we have a positive 2x, a negative 6x, and a negative 3x. The two negative ones total 9x's, so negative 9x, and then we have a 2x. That's going to leave us with 7 negative x's left over after two of the positives cancel two of the negatives. For the units, we have a negative 3, a positive 2, and a negative 5. Looking at the negatives, there are a total of 8 negatives and 2 positives. So two of the positives will cancel two of the negatives, leaving us with negative 6, or 6 negatives left over. So the simplified form is negative 7x minus 6. Commutative property of addition says if we have two numbers that are added together, the order of them does not matter. They still result in the same value, so both the left and the right sides have a value of 7. We've also learned that if we have subtraction, such as 7 minus 3, when we switch that around and we say 3 minus 7, well, that's not equal. The left side is 4 and the right side simplifies to a negative 4. So what we need to do when we have an expression like 3 minus 7 is we have to remember that this value here is a negative 3. And in that regard, as long as that negative follows the 3, we can switch our order like this, but the 7 is positive, even though we don't really see that. So as long as we say negative 3, positive 7, it's an equivalent expression. So the left side is equivalent to 4, and the right side, negative 3 plus 7, is also equivalent to 4. Okay, so here's a lesson on dealing with parentheses. Order of operations says we take care of the operations inside the parentheses first. So this on the left would be 1 plus 5, which is 6. On the right-hand side, if everything works out with just dropping the parentheses, we should have the same value. So on the right, following order of operations, 1 plus 2 is 3. And the next step, 3 plus 3 is 6. And we can see that the left side is equal to the right side by dropping the parentheses. Now let's try one with subtraction. So to see if the left and the right sides are equal. So following order of operations, the result in the parentheses is 3, So we have 4 plus 3 on the left, which is 7. On the right-hand side, we have 4 plus 5, which is 9. 9 minus 2 is indeed 7. So far that looks pretty good. Try this one. This time inside the parentheses is addition. Can we just drop the parentheses? So on the left-hand side, 2 plus 3 is 5. So we end up with 5 minus 5, which is 0. On the right-hand side, without the parentheses, 5 minus 2 is 3, and 3 plus 3 is, it's 6. So that is not equal to each other. So when the inside has addition, we can't just drop parentheses. We have to focus on, what's happening with that action? So let's take a look at this problem again. The 5 is having subtracted from it the value of 2 plus 3. So the 2 is actually being taken away, and the 3 is being taken away. So if we write that a separate action, first the 2 is being taken away, and then the 3 is being taken away. So now let's solve. 5 minus 5 on the left, which is 0. On the right-hand side, 5 minus 2 is 3, and 3 minus 3 is 0. So now they are equivalent. Well, based on the pattern of the last one, hopefully you see that there's a flaw in the thinking on the right-hand side. We can't just take away 4 and then take away 3. So let's confirm that. We've got 6 minus the quantity of 4 minus 3, which is 1. We have 5 on the left. On the right-hand side, 6 minus 4 is 2, and 2 minus 3 is negative 1. So sure enough, they are not equivalent. So if we think about what this means over here, 4 is being subtracted by 3, and that quantity is being subtracted from 6. So there's a lesser amount that's actually being taken away from the 6 because we're reducing that 4 that's being subtracted by 3. So really what we're looking at is we have 6 and the 4 is being taken away from 6, but that 3 that was taken away from the 4 is actually kind of like adding that 3 back in. That was a pretty mind-blowing concept, but let's look at it and see if it worked. Over here on the left again, we have 6 minus the quantity of 4 minus 3, which is 1, 5 on the left. And on the right-hand side, 6 minus 4 is 2, and 2 plus 3 is 5. So maybe it didn't make sense, but it worked. We'll relate that to the algebra tile, and we consider that we have 6 units, and in the opposite region we have 4 positive units and 3 negative units. Those 4 in the opposite region are going to be taken away. As opposites, it's really a negative 4. Those negative 3 that appear to be taken away are not really, because it's the opposite of taking away those 3. We end up adding those 3 back, or we can consider the opposite of a negative 3 as a positive 3. And again, 6 minus 4 is 2, and 2 plus 3 is 5. We'd still get the same value with or without the parentheses. Here we have an expression that involves grouping symbols, and order of operations says our number 1 priority is to deal with those grouping symbols first. Well, as it is, we can't add units with x pieces, so we can't do the operation inside, but we can remove the parentheses by rewriting the expression overall. So initially the first part here is the value of 3. No change with that. This expression here is being added, and we can add those pieces individually without changing any value. But the next expression has this subtraction, negative, minus sign, opposite sign, whatever you want to call it in front of it. Think of that as being the opposite of everything inside. So the opposite of a negative 2x and the opposite of a positive 6. Thinking about the algebra tile, I'm picturing I have a negative 2x. If I flip that from the opposite region to the positive region, it becomes a positive 2x. So that sign goes along with that piece. The positive 6x, when flipped, becomes the opposite, or a negative 6x. So again, that negative travels with the 6. And then at the end we have a negative 7. So now when combining this expression terms, we're looking for the common terms. Here is a negative 8x and a positive 2x. Negative 8 plus 2 is negative 6, is one way of looking at that. Or 8 negative x's and 2 positive x's, so you have to kind of picture in your mind's eye 2 of the negatives canceling 2 of the positives and leaving 6 negatives behind. For the units, we have 3 positives, 6 positives, that's 9 positives, and 6 negatives, and 7 negatives, that's 13 negatives. That's 4 more negatives than we have positives. So our end result is negative 6x minus 4, as simplified as it can be. So here's one to try on your own. Pause the video and see if you can solve this one. So hopefully it occurred to you the first thing to do is to remove the parentheses. So we have a negative 4 at the beginning. We are now going to be removing the parentheses with this first expression, and this sign says it's going to be the opposite of everything in there. So instead of a negative 3x, I will have a positive 3x, and instead of a positive 7, I will have a negative 7. Or instead of adding 7, I will be taking away 7. Plus 5x doesn't change. This next set of grouping symbols is already in the positive region, or it's being added. So when things are being added, I do not need parentheses, or if they're in the positive region, they're where I want them to be. So I'm just going to record those pieces. So now when combining like terms, I have 3 x's and 5 x's, and then some negative x's. So my positives are 8 positives, and then I have 4 negatives, and 8 minus 4, 8 plus a negative 4, leaves me with 4 positive x's. For my units, I have 4 negatives, and 7 negatives, and 3 negatives. All I have are negatives. I can just combine those together. The 7 and 3 make 10, with 4 more makes negative 14. So my final simplified form is 4x minus 14, or 4x negative 14. If you made an error in there, go back and see if you can find out where your misunderstanding is, and if you need to, watch the video over or ask questions.